Hello everyone, this is INE Foundation Lab 3 and section 6.5 VPN routing policy. Okay, before I conclude this section, let me refresh some BGP and VPN before concept, and I will come back and conclude this section. Okay, in MPLS board, there are some concept. One is MPLS with distinguished, with target, and VPN before. Let's start with MPLS with distinguisher. The RD is used to create a 96-bit address called VPN before address. And RD is a unique 64-bit number that is appended to the IP address, thus making it a 96-bit VPN before address. In other words, our VPN before address consists of 64-bit RD plus 32-bit IPv4 IP addresses. This is our VPN format, which consists of RD, colon, IPv4 address. This is our VPN address example. And the format used to configure RD is ASN colon 99. This is our good distinguisher example. This is how we can configure RD. RD consists of ASN colon NN. This is our VPN format, and this is our RD format. It allows PE or early adapters to determine to which customer a particular prefix belongs. And RD must be unique for different VIFs on the same PE or early adapters. To configure RD in our MPLS board, we configure RD on the IPVIF, or this is old-fashioned legacy, and this is new fashion, new mode, VIF definition. Under this VIF configuration, we simply configure RD by this command, RD, and specify ASN colon NN. RD is configured under our VIF configuration. Another MPLS concept is root target, or RT. The RT is a 64-bit or 8-byte BGP community, or it is extended community used to tag prefixes. It is used to control the distribution of VPN routing information between PU or LER routers. And it is used to control which VPN routes are imported or exported between VRFs. The RT acts as a tag for VPN routes, and it is attached to the BGP update messages. There are two types of root targets. One is export root target, or ERT, or the other one is import root target, or IRT. Export is uploaded when a route is exported from VIF table on PU router, and import is used by router to import route into its VIF. This is two type of root targets: export root target and import root target. We will see how we can use this in this scenario. Okay, this is how we can configure root targets in our MPLS. There are two main ways that we can configure root target. One is manual root target configuration, and the other one is automatically auto derivation. To configure manually, we simply under VIF definition, we type root target export, and we use root target export to export IRT, and we use root target import to import. And other ways we can also convert this auto derivation. This is how we can convert it by this root target export auto and root target import auto. This is automatically provides mechanism where RT can be automatically derived from the root distribution RD values on VIF. Okay, we also we can use export map there. I'm not gonna explain this in this scenario. For this scenario, we simply use manually root target conversion by root target import and root target export. Okay, another concept that we should know for this scenario or this section is how we can inject default root into BGP. There are multiple ways that we can configure inject or we can inject default root into BGP. One is we can using the network command. The network command adds method specific prefix including default root into BGP if it exists in our routing table. If we want to use network command, we have to make sure that the default root is present in our local routing table. For learning by static root or another protocol. Or we can use null zero command if there is no default root here. And use cases this simple scenarios where the default root is already present in the routing table. Simply under whatever BGP configuration, AS number with type networks 0000 and mask 000 and 0. This is how we can configure. We can inject default root into BGP by network command. The other way is using a static root with redistribution. A static default root can be redistributed into our BGP. This is how we can distribute our static root. We simply create default root if there is no default root but null zero command. I create a static root. I put root 000 and 000 and null 0. Then on the BGP, I simply redistribute this root into BGP with the static root. And it's used cases when you want to generate a default route regardless of actual connectivity. The other way is using default information originate command. This method forces BGP to advertise a default route even if it doesn't exist in its local routing table. Into other to previous ways, the default route should exist in the routing table, but for this method, where is this method? Default information original command, and but this method we can force BGP to add better default route even if it doesn't exist in our local routing table. Simply under routing BGP, we type default information original command, and the default route is injected into BGP without requiring it to present in the routing table. And its use cases when you want the BGP router to announce a default route regardless of its current state. The fourth option is conditional injection of default root. The default root can be injected into BGP only when specific conditions are met using a root map. This configuration is so easy. I create public list and permit default root, and I create root map. Specify the root map name, inject default. I permit 10. I match my previous created previous list. Match IP address, previous list, and this is my previous list name. Yeah. Then on the BGP, I type neighbor, remote address, root map, and my root map name. This is my root map name here. And out. We can use this method whenever we want to inject default root selectively based on policies or conditions. The another option to inject default into BGP is using aggregation. Aggregating to generate the default root. We can simply use aggregate address command to summarize our routes into our default route. The configuration is so easy. On the router BGP, we type aggregate address 0000000 and type summary only. This generates and advertise the default route based on existing BGP table entries. And we can use this method when we want to generate default route via existing BGP prefixes. The another method to injecting default route is MPLS route. We can use default route injection with MPLS VPN. In MPLS VPN, you can inject the default route into VRF using good targets or the distribution. This is how we can do this. We type upload VRF or VRF name and default route and next up. And on the router BGP configuration and on the address family VRF, we simply distribute static. We create. This is actually this is same as this one. This is distribution, but here we use VRF. We use create root, type VRF, and on the address family IP for VRF and VRF name, we distribute the static root. And the last one is leveraging BGP for default route advertisement. A BGP neighbor can be configured to send the default route using the default originate option. On the BGP configuration, BGP router BGP AS, we type neighbor, remote AS, and default originate command. The BGP neighbor, this our remote neighbor, will receive a default route in its BGP table, and we can use this case when we want to control the propagation of default route to a specific peers. And keep in mind, this method does not require pre-existing default route in our deep table. So these are the multiple ways that we can inject default route into BGP. Okay, now let's configure this section. Okay, let's review our previous configuration. This is our topology here, and in previous R6 switch to R5 4 3. Let's top show BIF. Okay. T is BIF. Okay, RT is Ethernet 0/1.233 is under VIF VPN-B. On R4, there is no VIF configuration. R5 via VPN-A, VIF VPN-A, and it's this interface. And these are the 100, 100. RT is 200, 200. Switch 2 is 100, 100, and R6 there are two VIF, one shared and VPN-A. This interface and this one. So this interface to share toward R4 and 100, 100 toward switch 1. This R6 and R5 are pure. This act as RP in the IMPLS world, PU right there. Okay. Okay. R4 will serve as central fiber for inter-VLAN traffic between VPN-A and VPN-B. And configure BGPS 6504 on R4 and set up an eBGP session to R6. Configure, we have to configure BGP, this BGPS on R4 on base. And set up eBGP session to R6 using this outgoing interface command. It's outgoing as source. It means that we don't have to use update or loopback command here. It will use its physical interface as update source. It is okay. As we use this is as update source. This is outgoing interface. And add method loopback 0 and its physical interface networks into BGP on R4. Okay, let's start by configuring BGP on R4. This is okay. This is R4. And R6. Okay, showdown pipe section dot a BGP. We have BGP neighbor between neighbor 10 and 3, and so this family. Okay, let's copy this one and add this configuration here. I have to create VPN BGPIS 65004 65. No BGP AS. I hard code my BGP router ID. Four four four, and I have to use my remote area should be 6 interface brief. It should be this interface one for this one. This is my remote area's IP address on R6. Then it should be enabled this one, and remote areas should be this remote areas. There is no update source, and this command should be removed. And under address family, I have to use neighbor this one and activate. Check my BGP 6.5 0. This 004, this 20, not 30. copy. This is my Sharpie protocols. There is no nothing protocol here at the moment. Config. I'm gonna have to conquer other side there on R6. Config T. Rotate BGP. Okay. Keep in mind that this R6 is RPE. Then this interface, if we are to do show VIF, it is on the this interface on the VIF shared. Then I have under this PGP configuration, I have to create VIF. We create address family, IPv4 unicast on top VIF, and I have to specify my VIF is shared. That's it. And here do show interface brief. And it is my remote address for this one. Neighbor remote address is this one, and neighbor activate. And it's up. Okay, we have conquered BGP between R4 eBGP session between R4 and R6 by using this its physical interface as source. Then we have to add beta loopback 0 and its physical interface networks into BGP on R4. Okay, in R4 we don't do show IP interface brief. There's only two interfaces. Then on this what a BGP address family IPv4 unicast. I simply distribute connected. Okay, now let's verify. Show BGP. Now I have next hop of 000 is been locally originated. Origin code is 00 and it is question mark. It means I redistributed this route into my BGP. Now on R6, try to show BGP VIF, and it is share and I can see this route that is as AS path from this AS path, and it is redistributed. Okay, now this is done. We have to configure network so that VPN A and VPN are not able to exchange route between each other. Okay, we can configure our policies or VPN policies in MPLS by using root target commands. And all traffic between VPN A and VPN B must first pass through R4. And the policy configured should allow VPN A PE routers R5 and R6 to exchange VPN A internal route between each other, and do not use any static route to encrypt this task. Okay, we have to use root target to force VPN A and VPN B to so that they cannot see each other's, and we have to also, because there is this R6 and R4. Let's verify. These are PE routers in our imperialist world, and R4 is our shared. It means that R4 should see VPN A and VPN B routes and all other routes from routes because it's a shared VPN. But VPN A and VPN A and VPN B should not see each other's routes. Okay, let's start this one. Usually, what should okay. In this scenario, we have three VPN. One is VPN A, three VIF VPNs. VIF, one is VPN A, VIF VPN A, VPN B, and shared. VPN A, VPN A has audio of 100, 100. VPN B has audio of 200, 200, and shared VIF has audio of 300 and 300. And R5 and 6 compared under R5 and R6 there is BIFA, and under what is 3 we have BIFVPNB. This is what is 3 and audio of 200, 200, and shared BIF is under what 6 either. On what 6 there are two BIF, one is VPNA and shared. Shared has audio of 300, 300, and VPNA has audio of 100, 100. R5 and R6 has same VPN A VIF 5 and 6, and it says so common network so that the VPN A and VPN B are not able to exchange between each other. It means that we should not use root target import from A to B and vice versa. It means on the under 5 and 6 on the VIF configuration 100, I should not use root target import 200. I should not import 200 on the VPN A, and on the VPN A I should not use import with target 100. But on the shared I have to use with target import 100 and with target import 200. Okay, now let's configure this section. Let's start with shared. It is here on R6. The VPN shared. Showdown. Top section VIF. On the VIF definer shared. Conflicted. I have idea 300. Okay, I first export my 300. We target export 300, and because it is shared, then I have to we target export 100. It is VPN A, and we target import 100 to 200 from VPN A and B, and we target import 100, and target import 200. Okay, and under VIF definition VPN A, on R6, because there are two VPN, one on R4 and on R4 and the other one on R6. I have to import this VPN either. This import this RT either 100. Target export 100, and to target import either, because our file also has VPN 100. Import and import from shared, it is 300, and I should not use target import 200 because 200 is for VPN B, and they should not see each other. It is on R6 done. Let's configure R3 showdown 5 section VIF config VIF definition VPN B. Only have to import 300 and not 300. Okay, I first export my 200. First export my 200, then import 300. I should not import 100 and RT and just be finished. Done. And let's configure R6 and R5. Show down section VIF and config. This is my VIF definition VPN. And because R6 also have 100, I simply we target export 100, and we target import. And we target import shared VIF. Yeah. Okay, this is done. Okay, now let's configure our P and inject our default into BGP. Let's inject our default on off on for have to inject BGP. I have to inject my default route into BGP. Rotate BGP. I will use default originate command. Yeah. While this using the default information originate command. It's not pre-existing default route into a RIP. Okay, on the address family IPv4. Enable default originate command. And last part is PE configuration. I have to configure R6 and R5. These are PE routers. So PE, I have to redistribute. I have to use mutual redistribution between BGP and its um, internal routing protocols. Okay, let's start with R5. Show IP protocols. I have to be between BGP and let's see on R5. Hold on. Okay, this is Hotel SPF 100 VIF VPN A, and this is Hotel BGP. This I have to use mutual redistribution between this routing protocol and this one on PE. Okay, let's configure this mutual distribution. Config T Hotel, and it is with BGP. AS and subnets and your information default information originate. I have to go to on the my BGP configuration, and address family IPv4 VIF VPN A, and we distribute OSPF 100. This is down and our 5 P configuration. That's it. And let's configure 6. To shut down. Okay, there is VPN. We have VPN A. Um, the same as our file. It is to this one subnet. And default information originate. And under rotate BGP. Address family IPv4. VIF VPN. A, and redistribute my OSPF. Done. So now let's wait for configuration. Start by R3. Show BGP VPN before unicast VIF VPN B, and RC default route originated. This is from R4. And um, switch 4, switch 2, show IP route BGP. Okay, switch 4. Should be switch 4. Yeah. And I can see my BGP. And this is 2020. Correct. Let's verify our file. Show BGP. VPN v4 unicast VIF VPN A. Okay, now let's verify BGP VPN v4 unicast we have shared on our 6. Now I can see our route here, and let's verify this. Now 5. Sure, BGP VPN v4 unicast VIF VPN A. And this route, this one 21 22, and these routes. Okay, now on our 4 short route BGP, and this is our BGP routes. Okay, I hope you have enjoyed this video, and thank you for watching.